Hello friends, the today's problem is kth largest sum contiguous subarray. Difficulty of this problem is medium. What's given in the problem? Given an array ARR of size n. Find the sum of the kth largest sum among the all contiguous subarrays. In other words, identify the kth largest sum from the all possible subarrays and return it. Means we have to generate all the subarrays, we have to keep track of all sum arrays, and we have to return the kth largest, means which is the kth largest sum from all the subarrays. We have to return that. We can see here 3 to 1, this is the given array, and k we have to return the second highest sum of the subarray. So 6 5 3 2 1, this is the this will be the sum of the subarrays. So 5 is the second largest subarray sum, so we are returning it. After that, here 2 6 4 1, here we have to return third largest. So 13 12 11 is the third largest, so we are returning 11. Expected complexity is n square log k and auxiliary space is log k. Topic tags are given like arrays, priority queue, algorithm. These are common. Now let us understand the problem first. This is the given problem. This is the array given just like 3 2 1, and k is 2. K is 2 means we have to return the second largest element. So we generate all subarrays. The sum of the 3 to 1 will be 6, 2 1 will be 3, 3 2 will be 5, and we will generate all the subarrays and keep the track of all sums. We will return kth largest, means 5. Here the answer will be 5. Here also all the subarray sums are tracked here, and third largest, which is the 11. Here the answer will be 11. So this will be the question. Now we will see the thought process and approach. Now we are coming to very brute force approach, which is the by using the nested loops and array. How can we solve by the nested loops and array? We will take two loops, means one outer loop and one inner loop, and we'll generate all the subarrays, which is we do generally by n square complexity, which is done by n square complexity. We will generate all subarrays, and we will keep track of sum in some array called sum array, which will consist all sum. Okay, and at the last we will sort the array. We will sort this array in the ascending order, and we will return the element like sum k minus 1 from the array. So this will be the our answer. But this has the largest space and time complexity, so this is not the optimal solution. We can do this, you can do this code by yourself. This is a very simple approach. Now we'll see some better approach to optimize the code and the time and the space complexity. So the second approach is better, which consists of the loops and the priority queue. Means we'll keep the same. The method of the generating all subarrays will be same, which will be same just like this. But here the catch is we are using the priority queue. Priority queue is the data structure which stores the element according to their, means we give the priority highest first or the lowest first. We will keep here highest first. We'll keep here the highest first. So here what will we do? We will generate all the subarrays, and we will each time will that sum into the priority queue, and after doing all the iteration we will take out all the elements, take out k minus 1 elements from the priority queue and return the top of the priority queue. So what will happen? We first generate all the subarrays, then calculate its sum and put the sum in the priority queue. Priority queue will arrange itself in the increasing order. Then we will pop out the k minus 1 elements from the priority queue. So the element which will be there will be the kth element, which will be the largest element. So we will return that, which will be the top element. Now this is also not the optimal approach, because here we are preserving all the sums in the priority queue. So priority queue itself takes the space to sort the array and the preserving the elements in the array. So this is not the good and the optimized approach. So the optimized approach will consist the sum things which will reduce the complexity of preserving all the things in the array itself, means priority itself. So in the optimal approach we will use prefix sum. Prefix sum means in the array we store the sum till the last index, means here 0 1 2 3 4 5. So one will have the sum until the 0, 3 will have the sum until 2, until 3, 4 will have the sum until 4. This will done in the prefix sum. This will be used, and we will use in the nested for loop. Nested for loop are must for this problem, so we can't optimize it, but we will, instead of calculating sum again and again and again, we will use the prefix sum approach to calculate the sum between the 2 points. Sum between the 2 points we will use the prefix sum. And priority queue we will use the, as we use in the earlier example, the same we will use the here priority queue, but in the another manner that will be understand in the code itself. So this is the code given, and this is the input given 1 2 3, and k is equal to second largest element we wanted, and this is the prefix sum. The sum till 1 is 1, the sum till 2 is 3 because 1 plus 2 is 3, the sum till 3 is 6 because 1 plus 2 plus 3 is equal to 6. So this is the our prefix sum array. This is our prefix sum array. We are taking the size here. This is our priority queue. We will talk later about the priority queue. Let's understand first the prefix sum. Then we are starting from the 1 and going up till equals to less than n, and we are storing the prefix sum, which is prefix I minus 1 plus array of I minus 1. This is the standard prefix formula. You can do the trial or the traverse by yourself to understand this formula. Then we are coming here. This is the main idea or the heart of the algorithm. We are not wasting our space in storing all the elements of the we are not storing all the sums in the array, but we just want k elements. So what we are doing, we are just storing k elements in the priority queue. We are only concerned about the k elements. So what we are doing, we are storing the sums in the priority queue in the descending order now. In the descending order means small to big, and we are storing in the only the smaller in the ascending order and in the k elements. So what we will do, when the priority queue is empty, we are directly pushing it. No problem. But when the priority queue is full and the sum which is greater than the top, means k size has filled, means our size which we have decided is filled now. K size is filled now, but the element which has the sum greater than the top means it deserves the position at the kth index. It deserves at the position at the kth, means it is the kth largest element. So we are popping the kth largest element, current kth largest element, and putting the new element there, new sum there. So how the code goes, first we are taking the priority queue. This is the syntax of creating the priority queue in the descending order, and here we are creating the prefix array. Now this is the code for making the prefix sum or the prefix array, and here the original traversal, or we can say the heart of the code is this loops, because we are taking two loops. These two loops, which is nested loop, having complexity n square. What we are doing here in sum, we are taking help of the prefix array, where what we are doing, prefix of j minus prefix of I, means we want the prefix sum between the 2 points, point j to point I, or we can say point j is behind, means point I is behind j. So we can write like this: we want sum I to j. So this will be used. So this will be used. Prefix of j minus prefix of I. So this will give us the sum of element between the point I to point j. So we don't need to calculate between the array of j multiple times. This will give us the total cost. Now here we are checking if the array size is less than k, then directly push it. If the array size is greater than k and top element also less than the current sum, now we are popping the last element and dropping our new sum, and at the last we are returning q top. Why q top? Because already we are preserving only k elements, and those k elements will be in the descending order. So the lowest element from those k elements will be on the top. So we are returning the q top. Now coming to the dry run of this code. Now suppose this is the given array and we transform it to the prefix sum by this code. Prefix sum by this code. Okay, so this is the given prefix sum code. Now let's understand. Now let's make the priority queue first. Okay, this will be our priority queue. Let's make it as a queue. This will be our queue. Okay, looking like the queue. Okay, then now the first element I0, and now j is 1. I0 and j is 1. Now what we are doing, prefix of 1 minus prefix of 0 means 1 minus 0. 1 minus 0 is 1. So we are putting it in the queue 1. After that j becomes 2. Prefix of 3 minus 0 is 3. It becomes 3. Then prefix of j becomes 3. J becomes 3. Prefix of 3 minus prefix of 0. So it becomes 6. So we are pushing it in the queue itself. Okay, but now the size exceeds because we have to only keep k elements in the queue. We have to keep only k elements in the queue. Here it is getting 3. So we are checking if the sum is greater than the previous. Yes, 3 is less than the 6. So we are removing 3. And we are keeping only the 6 here. So now the queue size is maintained as 2. Okay, so this is the now current conditions. This is the first largest and this is the second largest. Now iterations continues. Then we have to then I becomes 1 and j becomes 2. 1 and 2 minus 1 which becomes 2. But 2 is less than this 6, so we don't replace. Then I becomes 3. So 6 minus 1 becomes 5. 6 minus 1 becomes 5. So what we do 6 minus 1 becomes 5, but the thing is 6 is also greater than no, we are checking the top. So we'll check by the top. If top is less than new sum. Okay, we are checking top. So if top is less than sum, yes, sum is now sum is 6 minus 1 is 5. Now sum is 5. So we are checking with 1. Yes, 1 is low. So we are replacing it with the 5. Yes, okay. Replacing it with the 5. Now the indexes changes and now it becomes I stays as the 1 and j becomes 3. So now 6 minus 1 1 equals 5. So it is same as the our 5 here. Is same as our 5. So we don't change it. We don't change it. Now I becomes 2. Now the I becomes 2 and J changes. J now 3. J now 3. So 3 minus 2. 6 minus 3 is 6 minus 3 is 3. 6 minus 3. But 5 is greater. But 5 is greater. So we don't change with 3. We don't change with the 3. Now it proceeds. It becomes 4. But here now it becomes 4. There is no end. So iteration stops here. Then it becomes 3. It becomes 4. And it is 6. So and at the end of the entire iteration we have this q. We have this q. So we are returning the q of the top. So q of the top, this will be the answer 5, because we know the addition will be 1, sums will be 1, 2, 3, then 3, then 5, then 6. As we know by the naked eyes, this is the second largest, and our q tells us that 5 is the second largest. Means q returns 5, and we know k is the second largest. The simple idea is here. Simple idea is here. If the element is means the number of sums in the queue is less, then store directly. But if the number of sum is greater than k, then check the top. Why top? Because the top element is the kth lowest, and we are checking if the current sum is greater than that k lowest. So we are replacing it with that lowest sum. Means we are pushing the new sum in it, because this largest sum deserves that place, kth largest. So we are replacing with this line, and this reduces the time complexity significantly. Now while talking about the space and time complexity, time complexity is big O of n square and log k. Obviously n square because of we are taking the nested loops, and log k is because of we are using priority queue and prefix sum, all that things. Space complexity is big O of log k, which is used by the priority queue specially. Now let's run the code. This is the code of the given problem. Now let's run the code. Yes, test case is passed successfully. Now submit the code, and we are getting time limited. Why, I don't know. Let's submit it again. Yes, all test cases are passed successfully. Thanks for watching.